The eye is the most important tool in astronomy. This lab is designed to help you understand your eye better and see how closely it resembles the working of a camera. Eye has a lens just like the camera. Now this is the eye lens, and it forms an image of, it forms images of objects in front of it on the retina. Now this is the retina in place of the screen in a camera. Now how about focusing? In a camera, the focusing is done by changing the distance between the screen and the lens. Well, that's not very practical in the case of the eye. So what do? Well, we have a more sophisticated mechanism here. These muscles, called the ciliary muscles, can stretch and contract. When they stretch, the lens becomes thinner, and when they contract, the lens becomes thicker. Will help you to view a near object or a distant object. When you are looking at a distant object, the lens will actually stretch, making its power less. And when you are looking at a near object, the lens will become thick, making the power bigger. Well, what does the pupil do? The pupil is the same as the aperture in the camera. It is a hole that lets the light in. And what does the iris do? Iris is actually a muscle in front of it, and there is the iris defines the diameter of the pupil. The iris is like the diaphragm in a camera. It can close to become small when the light is very intense, and open to make the hole bigger, make the pupil bigger when the light is dim. Well, all these are important parts of the camera. When the image falls on the retina, the information is actually carried to the brain by the optic nerve. Now, there are what we call rods and cones that help you for color vision. And all these are very important parts of the human eye. I want you to have a fair idea of it so that when you use it for astronomical purposes, you know some very important functions that you're dealing with. All right, I want you to answer these questions. We talked about most of it anyway. All right, answer it in using full sentences as best as you can. Now let's talk about persistence of vision. You know what that is. When you look at some object for, say, some time, and if you look away, the image of that object actually stays in the brain for a short period of time, depending on the brightness of the image. I'm sure most of you have actually seen it. Now, practice it by looking at a bright object for, say, about half a minute, and then look at a white screen or something and see how long you can actually see that image persisting. And make a note at the end of this, your experience. All right? Write a sentence of 2, writing down your experiences. Okay. Next, we're going to look at what blind spots are. Well, you see, the place where the image is supposed to be forming here, the center of the optic nerve, there will be no image formed. In other words, that place is not really sensitive to light. And that is actually the blind spot. And we are going to locate your blind spot with a very simple activity. Now what you have here is a cross and a circle. Now I have suggested some steps here that you can take. So what I have suggested is keep your face at arm's length from the computer screen. Well, you must be looking at that picture. All right. Now cover your left eye, and while staring directly at the cross, move your face backward and forward. In my case, I'm actually doing it. I close my left eye, and then you got to be staring at the cross. Stare at the cross, and when you move forward slightly, I can see the black dot as well. Now stop at that position. Now once again, keep the computer screen at arm's length. Now your face is, say, between the cross and the circle. Close your left eye and stare directly at the cross. Move your face slightly forward until the dot becomes visible as well. Now measure the distance between your face and the computer screen and record it as AC. And repeat the same process for the dot. In other words, close your right eye, look staring at the dot. And as you either move a little forward or backward, the cross becomes visible. Stop there and measure the distance between your face and the computer screen. Record that also as AC. In other words, you have AC for the left eye and AC for the right eye. Then measure the distance from the center of the cross to the center of the circle, that distance, and record it as AB. And assume that the distance of the eye lens from the cornea is about 1.7 centimeter. You know what that distance is? Let's go back and take a look again. It is this distance. That's the cornea and that's the eye lens. That's roughly 1.7 centimeter. Now use all these measured distances to calculate your blind spot as DE equal to CD multiplied by AB divided by AC. All right. Do this 2 or 3 times and take the average measure of DE. Okay.